Hello students, today we are going to start the second chapter. This course is TMJ 241, News Probability Distribution and Sampling Distribution, and the name of the chapter is Normal Distribution. So students, normal distribution is one of the very important distribution, the statistics. It plays very important role in the statistics. It has many application, the different fields of statistics, or we may say in the different subject of statistics. This normal distribution plays very much important role. For example, this normal distribution has the application in the statistical quality control in order to construct the different control charts. Secondly, we can say there is one important theorem, one important application of this normal distribution, and that is the central limit theorem. We may say that is the beauty of this normal distribution. Why we call so? Because the central limit theorem state that for whatever the distribution, whether either it is discrete or continuous, so as we increase the sample size, the nature of the distribution or the graph of the distribution, it becomes look likes as of the normal distribution. And also in several another subjects, uh, the statistical inference in the testing, this distribution has a very important role. So in the many subjects, this normal distribution is very important role. And also in our day-to-day life, there are many examples for which if we find out the probability distribution of that data set in our many real life cases, uh, those follows the normal distribution. For example, we say the height of the distribution, weight of the students, or if we collect the marks of the students in some particular examination. So generally these data sets has the normal distribution. This data sets follows normal distribution. So, or in our day-to-day life, in many cases, for the many cases, for those data sets, they have normal distribution. So this is very much important distribution. So from today's lecture, we will start this chapter, normal distribution. So the content of our today's lecture is we will discuss PDF, and we will also solve at the end of the lecture some examples where we will identify the parameters from the given PDF. And also we will solve mean, variance and mode for this normal distribution. Okay, so let's start the session. First of all, let's see its PDF. Definition. Let capital X PDF, or we may call this as a definition of normal distribution. Definition. Let capital X be any continuous random variable, any continuous random variable is said to follow normal distribution with parameters mu and sigma square if its PDF is given by this PDF is given PDF of normal distribution is 1 upon sigma root 2 pi e raised to minus 1 half x minus mu sigma full bracket square. And the range is x defined for from minus infinity to infinity. Mu is also from minus infinity to infinity. And sigma square is positive. This is the PDF of normal distribution. We denote this as, its notation is x follows normal distribution with parameter mu, and so this mu and sigma square, these both are the parameters of normal distribution. Mu is location parameter, mu is location parameter, and sigma square is shape parameter. Okay, this is the PDF and this is the notation. Now let's see the mean and variance normal distribution. Mean and so mean is it is denoted by expectation of x. It is defined as integration x into fx. Okay, so x is from minus infinity. Now put the PDF here, put the values of we may say right here the PDF. PDF is 1 upon sigma under root 2 pi. Take 1 upon sigma under root 2 pi outside. E raised to minus 1 half x minus mu sigma bracket square into. So in the normal distribution for the derivations or whatever we solve in this chapter, for all the derivations we will use one common substitution, that is substitute. In all the derivations of this normal distribution, we will use one make common substitution, is substitute y equals to x minus mu 1. So if you differentiate this, you will get 1 upon sigma into dx, which implies dx is equal to sigma dy. And here the limits of x are from minus infinity to infinity. If you put the limits here, you will get y also minus infinity, infinity. This is the limits of y. Now put all these things in this integration. What we get here? Expectation of x is equals to 1 upon sigma under root 2 pi. Integration instead of x, this is y from minus infinity to infinity. Y is equal to x minus mu upon sigma. So this is also implies y is equals to x minus upon sigma. This also implies x is equal to sigma y, and this minus mu goes this side as plus. So this is mu plus sigma 1 upon sigma under 2 pi. This is x. X is mu plus sigma y e raised to minus 1 half. Instead of x minus mu upon sigma, put here y square, and dx is sigma. Now solve this. So 1 upon y is from minus infinity mu into e raised to minus 1 half pi square. See this sigma get cancelled here. This is dy plus 2 pi integration y is equals to from minus infinity sigma y. So take this sigma outside here, y into e raised to minus 1 half pi square. Okay. So now take this mu as a constant outside. I will take this 1 upon root 2 pi inside this integration. Why so? We will discuss. Y starts from minus in 1 half pi square into dy plus. Now see this integration is this is odd function. This integrand is odd function, therefore the value of this integration is 0. Now this is the PDF of standard normal 0 comma 1, and over the entire range the integration over the entire range of any PDF, it is 1. As we know that if fx is any PDF, then the integration over x fx dx always 1. So this is the PDF of standard normal. The answer of this integration is 1 mu into 1 plus 0, and it is equals to, therefore mean of normal distribution is mu. अशा पद्धतीने आपण या ठिकाणी मीनची व्हॅल्यू काढून घेतलेली आहे. नाउ लेट्स डिस्कस फॉर, लेट्स ट्राय टू फाइंड आउट द variance of, now let's try to find out the variance of normal distribution. So variance is defined as we can compute variance in two ways. Either we will find out expectation of x square, and we will use the definition variance of x is equal to of x square minus expectation of x bracket square. This is the one way, or we may use the definition of normal distribution. In this case, find out the variance of normal distribution, we will use the definition approach. Variance of x is expectation of x minus expectation of x equals to expectation of x minus mean of normal distribution is mu. All this expectation of x minus mu bracket square is integration x minus mu bracket square is equals to integration x minus mu square. If here 1 upon sigma root 2 pi e raised to minus 1 half x minus mu upon sigma bracket square x. X is from minus infinity to a constant outside 1 upon sigma root 2 pi. Take this as constant outside. X is from minus infinity to d. X minus mu bracket square multiplied by e raised to minus 1 half x minus mu sigma. As we discussed earlier, in whatever the derivations or whatever the derivations in normal distribution we have to solve, we will use one common substitution नॉर्मल डिस्ट्रीब्युशन मध्ये जे काही आपण डेरिव्हेशन करणार आहोत पुढे, सगळ्यांसाठी आपल्याला एक कॉमन सबस्टिट्यूशन वापरायची आहे. सबस्टिट्यूट y इक्वल्स टू x मायनस म्यू पण x इज इक्वल टू म्यू प्लस no need of this is dy is equal to 1 upon sigma dx. This implies dx is equal to sigma d. And as the limits of x are from minus infinity to infinity, limits of y will be also minus infinity to. Okay. Now solve. Therefore, variance of x equals to integration 1 upon sigma under 2 pi constant outside integration y is from minus infinity y is equal to x minus mu upon sigma. Therefore, x minus mu is sigma into y multiplied by e raised to minus 1 half x minus mu upon sigma is y square and dx is sigma dy. This sigma get cancelled here. What remains? 1 upon under root 2 pi y is from minus infinity to infinity sigma square into y square. Sigma get cancelled. Take this sigma square outside here. Y square into e raised to minus 1 half y square into. So if you observe this, this will be solved. Just wait. This is g of y. What is the g of y? G of y is equal to y square multiplied by e raised to minus 1 half square. This is even function. And as this is the even function, so integration of this will be 2 times integration from 0 to infinity y square into e raised to minus 1 half y square dy. Now if you observe this, this will be solved by using gamma function. That is, there is a formula integration from 0 to infinity e raised to minus a square y raised to n minus 1 into dy. This is equals to gamma n divided by 2 times a raised to. If you compare this with this integration, we get constant a is equals to 1 half and 2n minus 1 is equals to, solve this, 2n is equals to 3. This implies n is equals to 3 by. Okay. Now put the values. 2 sigma square on under root 2 pi gamma 3 by 2 divided by 2 multiplied by a is 1 half a raised to n is 3 by 2. So solve this, 2 upon root 2, it is simply, or you may cancel this 2 to get cancelled. So what remain? This is sigma square on under root 2 pi. Gamma 3 by 2 is 1 half into gamma 1 half. 1 half raised to 3 by 2. Let's solve this. 1 half raised to. This is equals to 1 upon 2. raised to 1 upon 2 raised to 1 upon 2 raised to 1 upon 2 is nothing but 1 upon square root of 2 raised to 3. This will be 1 upon 2 into, okay, so this 1 upon 2 raised to 3 by 2 is nothing but 2 multiplied by 2 multiplied by root. Okay, so now so this gamma 1 half is nothing but root pi. Root pi get cancelled. Okay, so this root 2, 2 and this 2. So if you solve this, 1 half into gamma 1 half. चुकलं या ठिकाणी, just wait. Into 1 upon 2 times root. हा 2 या ठिकाणी गेला, this 2 to get cancelled. This root 2 get cancelled. This root pi get cancelled. आणि हा 1 half कोणासोबत कॅन्सल होईल? हा 2 आधीच कॅन्सल झालेला आहे. Into a raised to n. Right? 2 times sigma square 1 upon sigma under root 2 pi sigma square. Okay, sigma square into y square, this is root 2 pi. Sigma get cancelled. This is 2 times. पर्यंत ठीक आहे. पुढे काय केलं? This 2 into a raised to n. Yes, this is correct. This 2 to get cancelled. So sigma square under root 2 pi. Gamma 3 by 2 काय येईल या ठिकाणी? 1 half. Gamma 1 half. Gamma 1 half म्हणजे root pi. This is 2 multiplied by 1 upon 2 raised to 3 by 2. That is 1 upon root 2 cube is 1 upon 2 root 2. Okay. हा 2 कोणासोबत कॅन्सल झाला होता? 2 सिग्मा स्क्वेअरचा. हा आधीच आपण कट करून टाकला ना, म्हणून ती गडबड झाली. हा 2 इथं राहू द्या ना अजून. 2 राहू दिला इथं. त्या ठिकाणी बघा हा 2 गेला, दिस 2 to get cancel, this root 2 get cancel, this 2 get cancel, root pi get cancel, only remains square. हे हा 2 आधीच कॅन्सल केला त्यामुळे या ठिकाणी कन्फ्युजन झालं. या ठिकाणी व्हेरियन्स ऑफ एक्स काय मिळालेला आहे आपल्याला या ठिकाणी? ऑफ एक्स इज सिग्मा. So what we have computed, if x follows normal mu comma sigma square, याचा मीन आहे एक्सपेक्टेशन ऑफ एक्स इज म्यू and variance of x is square. Okay, now let's compute the mode of normal distribution. Let x follows normal distribution with parameter mu comma square. df is 1 upon sigma under root 2 pi e raised to minus 1 half minus mu upon sigma brackets. Take log on both sides. We'll get log of f of x minus log of sigma under root 2 pi minus 1 half x minus mu on sigma square. Now differentiate both sides by x. So if you differentiate this, derivative of log of fx is f dash x on f of x. Derivative of this quantity is 0 minus 1 half. Derivative of this u square is nothing but 2 times x minus mu upon sigma 2 times u into the derivative of this x upon sigma is 1 upon sigma. Derivative of this minus mu upon sigma is 0. It is multiplied by 1 upon. So this implies dash of x is equals to fx 2 to get cancelled. You multiply this by minus, so it is mu minus x on f dash of x is equal to this one. So if you solve f dash of x is equal to 0, this implies f of x into mu minus x on sigma square, this is equals to 0. This implies, as this fx is PDF, so it cannot be the negative, so mu minus x on sigma square, this is equals to 0, and this implies x is equal to, okay. Now therefore this x is equal to mu, this is the root. So we may so we call this x is equal to mu as mode. If we find out the second derivative, if you put the value of x is equal to mu in that second derivative, that should be. So now find out the second derivative. F double dash x dash of x is equal to this one. Take its derivative. F dash x. Keep this mu minus x upon sigma square as it is. Firstly, differentiate this fx. Now keep this fx as it is and differentiate this. So respect to x na mu upon sigma square चा derivative 0 and minus x upon sigma square चा derivative minus 1 upon sigma square. Okay. आणि याच्यात जर आपण व्हॅल्यू टाकली at x is equal to mu f डबल डॅश x, या ठिकाणी x ची व्हॅल्यू जर म्यू टाकली तर हे काय होऊन जाईल तुमचं, this will be 0 if you put the value of x is equal to mu here. In the first part will be 0, and now this is the negative 0 plus this is the negative quantity. So at x is equal to mu f double dash x is less than 0. Therefore for normal distribution mode is so for normal distribution we have computed mean is also mu and mode is also. Okay. In next lecture we will also compute the median and it will be also mu, as this normal distribution is symmetric in nature. Okay, and now the last part of this today's lecture is let's take one or two example where we will identify the parameters from the given video. Example based on identification of identify parameters if fx is of x is PDF of normal mu comma sigma square. आपल्याला जे पीडीएफ असणार आहे ते नॉर्मल म्यू सिग्मा स्क्वेअरचे पीडीएफ असणार आहे. त्यावरून आपल्याला पॅरामीटर्स आयडेंटिफाय करायचे आहेत. पॅरामीटर्स म्हणजे म्यू आणि सिग्मा स्क्वेअर आपल्याला त्या ठिकाणी आयडेंटिफाय करायचा. e raised to minus 1 upon minus 4x is 4. So this is the PDF. Solve this or compare this. This if x is equals to, तर तुम्ही हे सॉल्व केलं तर काय मिळेल 1/5 under root 2 pi raised to minus 1 upon 50. If you solve this square, this is the square of x minus 2 bracket square. Okay. So this is, if you compare this with the compare with PDF of normal mu sigma square. ठीक आहे. नॉर्मल म्यू सिग्मा स्क्वेअरच्या पीडीएफ सोबत जर आपण कम्पेअर केलं, व्हॉट इज दॅट पीडीएफ एफ एक्स इज इक्वल्स टू 1 अपॉन सिग्मा अंडर रूट 2 पाय e raised to minus 1 half x minus mu square upon sigma square. So if you compare this with what we get, sigma is equals to 5 या ठिकाणी पहा 1 upon sigma under root 2 pi. So sigma is 5 and this is x minus mu bracket square. So mu is, now just check whether this 2 sigma square is equal to 50 or not. 2 sigma square minus 1 of sigma square या ठिकाणी काय is given 50. This implies sigma square is equal to 25. Sigma is, so the distribution is normal and the parameters are mu is 5 and the sigma square is. This way you have to solve these examples. Let's take one example for u. So let's take this example. F of x is equals to 1 upon 2 under root 2 pi e raised to minus 8 x minus 5 square. Similar example, you can easily identify this. The first part is identify probability distribution of x. Identify probability distribution of x. Secondly, once you compute, then the find expectation of and variance of 2x plus. Let's do this as your own. This example you have to solve on the same way we solve the first example. That's it for the today's lecture. We stop here.